In the next, let us have a brief overview of different kinds of ensemble methods. So we focus on the challenge that is faced by building ensemble methods. That is, we need to formulate, we need to construct base classifiers that we want them to be as independent as possible from each other, and all are from the same training data set. The key technique here we need to we employ is to resample randomly a new set of data samples from the original data sample, and we hope this resampling, the stochastic resampling, can give us some statistical insight of the distribution of the data. Mainly, we can consider different ways of reusing this stochastic resampling. Different ways of carrying out this stochastic resampling. And there are different families of the ensemble algorithms: bagging, random forest, and boosting. The idea behind bagging is simple enough. You just randomly resample the original data set and get resampled new data set and train the base classifiers, the base predictors based on the resampled some data set. We do that multiple times and get multiple predictors. Admittedly, in such a way, because all of those resampled datasets are from the same original dataset, so you do not expect that they are totally independent from each other, but they do reflect some of the statistics of the original data distribution, which is unknown and which is the golden standard. So in this way, the bagging can generate some connected but somehow independently trained base predictors, which makes a viable ensemble. If you generalize the idea a little bit further, think about that. The mostly commonly used base classifiers are decision trees, and decision trees make decisions using particular sets of data attributes. So if you allow each tree only a subset of the data attributes and make it a random subset, this will give you different trees in the ensemble. So in this way, if you resample both the data samples and the data attributes and build a classifier on this subset, that give you the family of algorithm called random forest. There's another way, more sophisticated way of doing the resampling. Rather than uniformly resample the original dataset, you can give weights to each of the datasets and generate resampled data according to the weights. In this way, we get a family of very useful algorithms, which is called boosting. Here we have a very brief view of what boosting, the algorithm of ADABOOST, which is one of the most widely used boosting algorithm. The algorithm takes multiple iterations. In each of the iteration, we reweight the data sample and resample a new data set according to the reweighted data samples. The samples are given weight according to how challenging those individual samples were in the previous round of prediction. If a sample proved to be very challenging, very difficult to predict, which means if you have a classification problem, some samples may lie close to the boundary between two classes, which makes them they are very important samples. We want the classifier to put more interest, to put more weights in those kind of samples. So we give those sample more weight. And on the other hand, for each individual classifiers, the base classifiers, they are also weighted. They are weighted according to their performance on the data samples. This is natural. You want a stronger classifier have louder voices. Classifiers have louder voices in the voting in the ensemble, and for weak classifiers, you do not want them to disturb the classification too much. So that is the basic logic. After this, let us first have a look at a very simple example, which is not about learning anything, but it gives us a concrete demonstration about what statistical significance, what statistical characteristic we can gain insight into the data distribution by resampling.